Hi there, it's Professor Monty. Let's look at exponential functions and their graphs. Okay, an exponential function has a variable in the exponent. That's all there is to it. So for instance, if I have a function f of x equals b to the x, now b, the base, is just going to be some number. But the x up there, that's going to be the exponent. Now b has to be positive and it can't be equal to 1. I've set that out here. So the base is just a number, a positive number not equal to 1. And then x can be any number at all. Okay, so that's what an exponential function is. It's as simple as knowing, oh, if the variable's in the exponent, it's an exponential function. They want us to graph f of x equals 2 to the x. It's exponential, the variable's in the exponent. The base is a constant. So what I'm graphing is y equals 2 to the x. And so since I don't know what this looks like, let's just plot some points. And what I want to do is I'm going to plot some negatives, I'm going to plot some 0, some positives. And so I'm plugging in y equals 2 to the x. So remember, if I have 2 to the negative 2, that's 1 over 2 squared, which is 1/4. So that's 1/4. Similarly, if I plug in a negative 1, it's 1 over 2 to the 1, or just 1/2. Y equals 2 to the 0. Remember, any non-zero number to the 0 power is always equal to 1, so that's a 1. 2 to the 1 is simple, that's a 2. 2 to the 2, 2 squared is 4. And 2 to the third, 2 times 2 times 2 is 8. So I've got a bunch of points. I'm going to graph them. So let's see, I'll go over here to negative 2, here to positive 3. I go up to 8 in the y direction. Okay, so at negative 2, let's see, if this is 1, that's a half, that's quarters way down here. Then I'm at a half for negative 1. Then I go up to 1. Then I go up to 2. Then I go up to 4. Then I go up to 8. And notice this is what's common with an exponential function. They always have the same shape. Let's draw it in red so it stands out. It's going to look something like this. And notice it's growing slow to begin with, and then it starts growing faster and faster. That's what they refer to as exponential growth. So if I look at this, what's happening, the 2 base, instead of going up by 2 each time, it doubles each time. It's a multiple of 2. So 1/4 to 1/2, that's actually doubling. It's easier to see now. 1/2 to 1 is doubling, double, double, double. So it doubles each time x goes up by 1. It doubles because 2 is the base. And so notice it's never coming down below y equals 0 in this case, because no matter what 2 to any power is always going to be a positive number. So for this graph, it's always going to be above the x-axis. There's a horizontal asymptote here. Okay, that's the basic shape. It's always got this basic shape. It's kind of this curved shape. It looks kind of like a hockey stick, or some people say it looks like a banana. It's always got that shape. If we remember that, we're doing well. So I can graph, since I know what this basic graph looks like, I can graph real easily using translations, reflections, that kind of thing. So y equals 2 to the x, this graph, but then minus 4. Remember that minus 4 is just going to move the whole thing down 4. If I wanted to plot points, it would just be subtracting 4 from each of these. So it takes this graph and it moves it down 4. So instead of at 1, I'm going to go down 1, 2, 3, 4. It's going to be at negative 3. Now, there's going to be a vertical asymptote, or a horizontal asymptote rather, at y equals negative 4, because it moved down 4. This asymptote was at y equals 0. But the graph's going to look the same. It's got that same shape. It goes through here. Instead of going through 1, it goes through negative 3, because I moved it down 4. Done with my graph. This graph, this negative, remember, that's a reflect in y, or across the x-axis. So that's just going to flip that whole thing down. So instead of this graph, it's going to look like this. Again, y equals 0 is going to be the horizontal asymptote. But it's got that basic shape. All the exponential functions have that basic shape. It just depends what you do with them. If you remember the basic one, you can get to the other ones real quickly. If you need to plot some points, plot some points. but ideally you won't have to since now you know if they